The dying Soviet cosmonaut finally broke his silence after decades of fear. On his deathbed, he revealed shocking photos he was never supposed to see, secret Soviet vehicles and strange structures hidden on the dark side of the moon. For years, he lived in terror, believing his superiors were building a classified lunar base without telling even their own staff. Why keep such a massive operation hidden? What were they really doing up there? The truth, he revealed in his final moments, will send chills down your spine. The Vanera. What did the Soviets do when they wanted to explore one of the harshest planets in our solar system? They created the Vanera program to investigate Venus. In the early 1960s, they decided it was time to send probes to Earth's sister planet, which is known for its extremely high temperatures and crushing atmospheric pressure. Over the years, they launched 13 probes toward Venus, and an impressive 10 managed to reach the surface or transmit data while descending. Despite thick swirling clouds of sulfuric acid and surface heat hot enough to melt metal, these probes returned vital details about chemical composition, ground conditions, and atmospheric layers. They took black and white images of a rocky terrain surrounded by a dim orange sky. Each probe soon succumbed to intense heat and high pressure, often failing within minutes or hours. Even brief contact, however, let Soviet scientists gather groundbreaking planetary science data rarely obtained by any other nation at the time. By exploring Venus so aggressively, the Soviets demonstrated their willingness to push boundaries and propel planetary research further. The Vanera missions, though overshadowed by the lunar race, stand out as a bold example of early interplanetary exploration. They showed how resolve combined with innovative engineering could capture significant insights from one of the solar system's most inhospitable realms. Alexei Leonov. How did the first spacewalk ever occur? It happened thanks to Alexei Leonov, more widely spelled as Alexei Leonov, who stepped outside his spacecraft on March 18, 1965. Soviet leaders kept quiet about this bold plan, fearing a disaster if something went wrong. Leonov floated in space tethered to his vessel, becoming the first human to drift beyond the protection of a cabin. During this historic extravehicular activity, he marveled at Earth below and the dark expanse around him. He quickly realized spacewalking was far riskier than anticipated. Leonov's suit expanded in the vacuum, forcing him to vent excess pressure before he could fit back through the airlock. This hazardous maneuver nearly cost him his life. Only after he returned safely did the Soviet Union trumpet the achievement, showcasing another major first in the realm of human spaceflight. Later in his career, Leonov contributed to training strategies and safety protocols for future spacewalks. His success also propelled the Soviet program to look beyond short orbital flights, hinting at activities like satellite repairs and potential station building outside spacecraft walls. Today, Alexei Leonov remains celebrated as the pioneer who proved that humans could work outside a pressurized cabin, paving the way for countless spacewalks on stations and satellites. The OKB-1. Do you ever wonder where the Soviet Union designed and tested its groundbreaking spacecraft? That secret lay in the OKB-1, an experimental design bureau near Moscow. This facility served as the creative engine behind much of the USSR's early rocket technology. Engineers there refined ballistic missiles into launch vehicles, eventually giving birth to the famous R-7 rocket that sent Sputnik and Yuri Gagarin into orbit. They also handled cosmonaut training, ensuring each candidate was prepared physically and mentally for unknowns in space. The OKB-1 originally focused on missile development, but it soon expanded into designing crew capsules and life support systems. Secrecy cloaked almost every aspect of its work. Family members and the broader public knew little about what happened behind locked doors. The Bureau's top minds had to juggle political pressures, funding limits, and the fierce timeline of the Cold War space race. Following the death of visionary chief designer Sergei Korolev, the OKB-1 continued to shape Soviet designs, working on space station modules and advanced rockets. Some successes were revealed to the world while other missions remained hidden. Even after the USSR dissolved, the OKB-1's legacy of innovation endured. Much of modern Russian aerospace engineering can trace its lineage back to the breakthroughs and dedication at this legendary site. Mars? Are you curious about the planet that captured Soviet dreams once the moon slipped away? The Soviets set their sights on Mars, hoping to reignite their cosmic leadership after missing the first lunar landing. To some policymakers, a crewed mission to the Red Planet could overshadow Apollo's triumph, restoring Soviet prestige on the interplanetary stage. Yet achieving that goal was more complex than sending a lone craft into Earth orbit. Plans called for habitats, multi-year life support systems, and robust propulsion for the massive journey between the planets. Some engineers proposed nuclear rockets, while others suggested huge chemical boosters reminiscent of the ill-fated N1. Testing was perilous. Attempts to put early probes around Mars often ended with communication losses or incomplete data. Even so, the Soviets did manage flybys and partial orbits, gathering essential information about atmosphere and terrain. Back on Earth, political and economic problems derailed these grand schemes for a Martian colony. The Soviet Union struggled to maintain funding, and any potential crewed trip to Mars repeatedly stalled. Some officials also argued that focusing on space stations brought more practical benefits. Despite these setbacks, the dream drove Soviet engineers to envision large-scale missions and planetary bases. For a while, Mars represented the next leap that might redeem their space program's ambitions. The Russian Space Shuttle. What did the Soviets do when they noticed the US Space Shuttle's unique capabilities? They created the Russian Space Shuttle to match or surpass NASA's design, often known as Buran. This project emerged in the 1980s after KGB agents reportedly secured technical data from American shuttle blueprints. Engineers spent years replicating the shuttle's shape, thermal tiles, and cargo capacity, culminating in a visually similar orbiter. The USSR triumphantly launched their shuttle in 1988 using the Energia rocket. Remarkably, it carried no crew but successfully orbited Earth twice before making a fully automated runway landing. This demonstration showcased advanced autopilot and computer control that even NASA's shuttle never fully matched. Despite that technical victory, the program soon fell victim to financial constraints. When the Soviet Union collapsed, government backing vanished. Without resources, further flights became impossible. The orbiter languished in hangars, with some prototypes eventually scrapped or damaged in accidents. Yet many aerospace experts still consider the Russian space shuttle an ingenious feat of engineering. It briefly allowed the USSR to compete in reusable spacecraft technology. Though short-lived, the program underlined a fierce determination to maintain par with American achievements even as domestic troubles doomed future flights. Zondak. How did the Soviet Union gather deep space knowledge beyond low Earth orbit? They employed the Zond program, sending spacecraft from 1964 to 1970 to investigate the Moon, interplanetary space, and cosmic hazards such as solar radiation. Each Zond mission tested new technology or carried instruments to measure conditions for potential crewed landings elsewhere. Some flights included biological specimens like turtles or seeds to study how life reacted to extended microgravity. Among notable missions was Zond 3, which soared past the Moon and captured images of the hidden far side before forging ahead on a solar orbit. These images helped map craters beyond Earth-based telescopes' reach. Meanwhile, other Zond missions encountered propulsion failures or communication breakdowns, reflecting the difficulties of exploring beyond Earth's sphere of influence. Even partial successes, though, fed valuable data into the Soviet Cosmonaut core knowledge base. Observers in the West wondered if Zond heralded an upcoming Soviet lunar landing. In reality, internal struggles and inconsistent rocket reliability hindered broader goals. Nonetheless, each Zond mission played a distinct role in refining attitude control, re-entry techniques, and spacecraft shielding. Although overshadowed by crude achievements, the program helped pioneer routes to the Moon and beyond, demonstrating that robotic probes could pave the way for future travel. The Salyut Space Station. What if staying in orbit for weeks or months could teach us lessons about living beyond Earth? That was the rationale behind the Salyut Space Station, sometimes spelled Salyut, which the Soviet Union introduced in 1971. It gained fame as the world's first space station, aiming to explore the feasibility of lengthy human stays. The initial Salyut 1 module tragically lost its returning crew because of a decompression mishap, but the program pressed on. In forging new modules, Soviet designers enriched each station with better life support, docking systems, and scientific labs. Crews practiced long-duration missions, some lasting weeks, then months. Experiments ranged from microgravity research to Earth imaging as the Soviets realized a permanent orbital platform gave unique vantage points for science and surveillance. Over the series, each upgraded Salyut station offered expanded capabilities. Although they publicly highlighted scientific aims, rumors circulated that some Salyut stations harbored defense hardware. The USSR, valuing secrecy, kept official details opaque. Nevertheless, the knowledge gained proved indispensable for constructing larger stations later, including Mir. By pushing boundaries in crew health and station operations, the Salyut space station line advanced capabilities for sustained human presence in orbit, planting seeds for what would become the framework for modern international cooperative stations. Military Space Program. Are you aware that not all of the Soviet Union's orbital ventures were purely scientific? Indeed, a secret military space program coexisted alongside public missions.